Hello and welcome to the Prime Factors Kata. So first off, let's talk about what a kata is. Kata comes from karate and is a daily practice to improve skills. And that's what we're going to do here. We're going to apply that to our software development and use that to practice our test-driven development or TDD skills with a little bit of practice with our behavior-driven development or BDD. And what we're going to use is we're going to use this prime factors example. In mathematics, prime factors are a set of prime numbers being any number that is only divisible by 1, so like 2, 3, 5, so on, that can be multiplied together in order to equal a given number. In this example, 4 would be 2 and 2. So if you take 2 times 2, you get 4. Prime factors also completely divide a number and cannot be split into more factors. So if we take the example of 8, if we divide that by 2, our first prime number, we get 2 and 4. And we already know that the prime factors of 4 are 2 and 2, so we end up with a list of 2, 2, and 2 as our prime factors for 8. Prime factors are also listed in ascending order. So if we have a larger number like 30, then our prime factors would be 2, 3, and 5 given in that order. So that's an introduction to the prime factors and what a kata is. So what we're going to do is we're going to follow this story. So as a math student, I need to have a way to determine the prime factors for a given number so that I can check my math homework. And here's some acceptance criteria. When given a 0 or 1, we return no factors. For prime numbers, I'm only going to return the inputted number. So if I give you a 5, I get 5 back. Multiple prime factors are listed for a given integer in ascending order. In this example, 60 results in a prime factors list of 2, 2, 3, and 5 in that given order. So that's the story that we're going to work to. And let's talk a little bit about test-driven development. So we have an iteration that we use when doing test-driven development. That's red, green, refactor. And we'll be using those terms a lot. Red means that we have a failing test that needs to be made green, make it a passing test. After we have it green, we're going to go to refactor, where we'll improve or clean up our code. And this could be our production code or it could be our testing code. And that's this iteration that we're going to do over and over again. And we're going to keep those really small. Now, there's some rules to TDD. The first rule is that we only write production code when we're in that red state of having a failing unit test. Okay, so we don't want to be writing code and then testing it. The whole idea of test-driven development is to write the test first. We don't want to write more of a unit test than is sufficient to fail our production code. And compilation failures are a type of those failures. So if we hit a compilation error when we're writing a test, we want to resolve that before we move on because we've hit a failure. And we'll see that as we roll through the kata. We also don't want to write more production code than is necessary to pass one of our failing unit tests. Like we don't want to be in our code and go, oh, you know what? I know I'm going to need this later on, so I'm going to write this now. We don't have a test to cover that, so we shouldn't be writing that code. We just want to write the minimum amount of code needed to pass a test. So those are the rules that we're going to be following in this TDD kata. And also some notes on project setup. So I am using IntelliJ with the Gradle project here. And we're going to be doing this in Java. And I'm also using JUnit Jupyter for this. So in my Gradle settings, or in my build.gradle file, I have test implementation and my runtime only set up for that. And I'm also using for the behavior test, I'm using Cucumber Plus with these implementations. So in my build.gradle file, under dependencies, you can see I have here the Cucumber, and up here is my Jupyter settings. And that's all the settings that we need for our project. So if we take a look at our behavior that we're looking for, so I've set up these behavior tests ahead of time. have a feature file that contains two different scenarios, and these come right from our story, and so they look like our story too. Given a student, when they make a request for the prime factors of 60, then I return a list of 2, followed by 2, followed by 3, followed by 5. And that matches what we saw in the acceptance criteria. They didn't give us an example for a prime number, so for this one, we just say, given a student, when they make a request for prime factors of 5, then we get a list of integers that just contains 5 as our return. As a challenge, you could take on 0 and 1 acceptance criteria as well and add that as a scenario. So with that, let's go ahead and jump into our kata, and I'll leave a marker here in the video in case you're doing this as a daily practice. So we're going to start with our package that I have defined here. I'm going to create my first test class. We're going to call this prime factors test. And we're going to write our first test. So we're going to use this test annotation from Jupyter. We'll let that import like that. We see we have our first compilation error because we need a method signature here. So I could just call this test or test 1 or test 0, but I want something a little bit more descriptive so that when I come back later, I know what this test is doing and what its responsibility is. So I want to test for the prime factors of 0. So we're going to go ahead and start with that first AC, starting off at 0. And now we got to think about, well, what do we expect to get out of this? So if we look at our ACs on our story, we know that we're going to expect an empty list. So we're going to use an assertion here, and we'll use the assertions from Jupyter. We're going to say equals, and you can see that the signature is assert equals. We're going to put in our expected result, then our actual result. So what are we expecting from assert equals? We are expecting a list. We'll use the util list there of nothing. We expect an empty list. And so what are we going to call for our actual? Well, we're going to do some type of class like prime factors, and we're going to do get prime factors for an inputted number of 0. So here we can see we have a compilation error here. So it doesn't know where to find that because we haven't created anything yet. So we need to create a class prime factors. Now it's going to go ahead and try and put this in the same package that we have here, but we don't want it in our test source structure. Sometimes you'll see it in this drop down, but we don't. So we're just going to hit this ... go find our main. This is where we want our production code to live. So we'll use that, hit OK. We see that it's good there, and hit OK, and we've created our class. There's no errors in the class, so we can jump back out. We still see that we have an error in our test by the red squigglies in our project structure. And we see, oh, well, we don't have the method either. Well, this one's pretty easy. We just hit the create method here, and it's going to give us a template. So we're going to return a list of integers here. We don't want to use the name I. We're going to just call this our input. And we hit enter on that, and it's going to return a null. This is probably all we need in order to pass that first test. So I've got this reduced down here. So we can go back to our test, and you can see we've got a couple different ways of running this. So if we've already run a test of some type, we can hit this play button down here. We can run the individual test by hitting this play, or we can run all of them in the test class by using this play button here, and it'll ask you if you the way you want to run it. We're just going to do a straight run. And you can see we have a failing test. So in this structure, we go all the way down to our test, and we can see we expected an empty list. I'm going to make this a little bit bigger. We expected an empty list, but we actually got null. So now at this point, we are in our red state where we need to write some code in order to make it pass. So we go to our prime factors class, and to fix this, we're going to write the bare minimum, which would be to return a new, and we'll just use an array list. All right, so that's the bare minimum. Run it. We are now in our green state. So now we're going to look at a refactor. Well, we've got this weird E thing in here that we don't need. So we'll get rid of that. We're not using our input either. You can see it's grayed out because we're not using it. But this is going to cause us issues if we try and take this out because our method signature is being used in our test to pass in the number that we want to test. So we're not using it yet, but we're going to, so we don't want to take that out. We go over to our test, and there's really nothing here to refactor yet. So, we've got one line of test code. So if we rerun this, so anytime we do a refactor, we rerun, make sure we're still green. We are. Let's go to the next test. So the next test in our AC was for the number 1. We want to make sure for 1, we're doing the same thing of getting that empty list back, which, given what we have, we expect that to probably pass right off the bat, right? Because this code works for both 0 and 1. If I was a betting man. So we'll pass in 1 here. Everything's good here. Everything's good in our structure. Go ahead and run that. And yeah, it passes. All right, so we didn't do anything. We still haven't gotten to a red state. We wrote the test. It passed. We're still in our green state. We're still trying to get to a red state. So let's go to our next number, which will be our first prime number. And the first prime number is, of course, 2. So I'm going to use our assertions again. Assert equals, and we're going to do a list of 2 is what list of 2 when we do our prime factors. I'll get prime factors for the number 2. All right, so our test doesn't show any errors. We're not seeing any errors in our project tree. We run it, and we do have a failing test. Now we're back to our red state. So we expected 2, but we got an empty list. So we go back to our code because now we've got to code something to make this pass. I'm just going to highlight this list here, and I'm just going to use my tools to introduce a variable. It's going to suggest a list of integers. That's what we want. We're going to call this prime factors and hit enter. And now we have a variable that we can use. So we know 0 and 1, we want an empty list. We don't want to add anything to this. So we're going to use an if condition that if our input is greater than 1, we want to do something. And we're going to take our prime factors list and add the number 2 to it. All right, so that should be enough code to get this to pass. So we rerun our test. Sure enough, we're passing. So now let's look at some refactors. So I only have one line in this if statement, so these curly braces are actually extra. So I'm just going to go ahead and remove those. And I could leave the white space in for readability, but I feel like being a minimalist today, so I'm going to one line that. That cleans that up. I've done some refactoring. I want to make sure I didn't break anything, so I'm going to rerun my tests, and that looks good. So now let's take a look at our test code. Typing this assertions and prime factors is really redundant, and I have a way of not having to do that every time. So what I can do is if I go to my show context menus on this, I can import this statically, and that's going to remove that part of that. I can do the same thing for prime factors, refactor that. Oh, sorry, not refactor. Show my context in static import on that. And now I've made this a little bit easier for not only writing, but for the readability as well. So I made a refactor there, rerun my tests, make sure they're still green. They are. Okay, now it's time to try and get back to red. So we'll do that with another test. So our next number in the list would be 3. Well, this is also another prime number. Let's just make sure this one's working. Prime factors of 3. Everything looks good here. No red there. Run the tests. Oh, and it failed. So we're not handling all of our prime numbers yet. So we expected 3, but we actually got 2. Well, of course, because we told it to add 2 here. So if we're better than 1, let's go ahead and add our input to the list instead. Run that, and now we're green. This is a very small change. We didn't add a whole lot of code. We just replaced a magic number of 2 with a variable name. So nothing really there. If we look at our test, these are nice and concise. So we're going to move on to our next test. Our next test would be for the number 4. 4 is going to be interesting for us because now we need a list of factors. 4 is the first one that's going to have more than one prime factor. And we're going to be expecting a list of 2 and 2 for this, because 2 times 2 is going to be 4, and we get our prime factors of 4. Okay, everything's happy here. We're good in our project structure. We run our test, and yep, that fails. We're back to red. We expected 2, 2, got 4 as our actual result. So how are we going to do this? Well, let's see if our input can be divided by 2, which we're going to use the modulus operator for that. So we're going to say if the modulus of 2, which means if we divide input by 2, what is our remainder? Well, if our remainder is equal to 0, we know we were able to divide that by 2 evenly. So if that is the case, we're going to take our list and add the number 2 to it. And then after we've done that, what we have left is that we have to take our input and we're going to have to divide that by 2 and replace that value. Oops, wrong slash. There we go. So when we're going to replace that value by the value divided by 2. So when we start with 4, we go through this if statement and we divide it by 2, we're going to get 2, or we're going to get the 0 because it can be divided by 2. We'll add that 2 to it. Then we're going to take our input divided by 2, so now we're going to be left with a 2, and we're going to let it fall through into this one. It's greater than 1. We'll add that 2. That should give us our 2, 2. If we run that, then we see, oh, yeah, well, we failed 0. As we got, that's interesting. So instead of an empty list, we got 2. So when we input 2, or when our input is 0, 0 divided by 2 is 0. So we added 2 to there. So we can fix that by adding an AND operator on this and saying input is greater than 0. Now if we run that, we're green. So we've written the least amount of code that we can there. In order to pass that, a refactor step we could do is we could reduce this line to a divide equals like that. That cleans that up a little bit. And I think that's probably it. We'll rerun our test, make sure we're still green. And we know that our tests are probably as clean as we're going to get them. So we can move on to our next test. And this test will be, for our next number in the series would be 5, but 5 is prime, and we've pretty much covered all of our prime number scenarios that are interesting. So let's try 6 and see what happens when we get a 6 in here, because 6 is interesting because the prime factors of 6 are 2 and 3, not 2 and 2. So if we do prime factors of 6, let's see if that works. Oh, it does work. So we weren't sure. We tested it. We know we're good. We didn't have to make any change. We never really got to our red state on that one, so we move on to the next test. And because that wasn't significant, we could actually remove that test if we wanted to, because it didn't actually test anything of interest. But for the sake of the kata, it was a good practice, so we'll leave it in there. So for 8, we're expecting a list of, and so we skipped 7 because 7 is prime. So we're expecting a 2, 2, and 2 here. And we want to do our get prime factors for the number 8. Happy here, run our tests. Now we're back to our red state. So we expected our 2, 2, 2. Well, we got 2 and 4. So if we look back at our code, why is that? Oh, well, because we're using an if statement. We divided it once, but we need to do this multiple times in order to get a repeating 2. So if we change this to a for loop, and we don't need a different variable, we just need to repeat this step a few times, and we don't need an incrementer on this because we're already changing input as we go through. So that should be the least amount of code that we need to do to get this to pass. Sure enough, it passes. So now let's take a look at a refactor here. So this is actually our incrementer decrementer that we would use for our for loop. So we could move that from here up to here and reduce that line of code. And we run that again. Make sure we're still green. Oh, and the other thing is this is now just a one-line for loop. So we could remove our curly braces here. I'm going to stick with my minimalist theme and do that. So we didn't need those curly braces. Rerun that. That should still work fine. Does. Okay, we're back to green. We know we don't have any refactors on our test. So we move on to our next test. And this will be the final test of our kata, which will be to test the prime factors for the number 9. And here you should be starting to feel a rhythm, if you haven't already, of how we're writing these tests. Our prime factors for 9 are 3 and 3. And when we pass that, we know our test is happy here, we're happy out here. Run it, and we're back to red. And what we got, we expected 3, 3, but we just got 9. So if we look at our code, why is that? Well, because we're only testing for the value of 2. So in order to fix this, what we're going to do is we're going to introduce a new for loop. And this time we're going to need something that we're going to call a candidate. And we're going to start this at 2 because that's the number that we're going to start with for replacing, because that's where we start here. That'll take care of that magic number of 2 there. And we're going to do this as long as our input is greater than 1. Because once we hit 1, we know we're done. And we're just going to increase this candidate by 1 every time. So we're going to do that. Drop this for loop in there. So just do a little stylizing for that. And what we need to do here is anywhere we have that 2. So here we're checking it for a modulus. We're going to now check our candidate instead. We got our input greater than 0. And here, instead of dividing by 2, we're going to divide by our candidate. And if it does succeed in being evenly divisible, we're just going to add our candidate to the list. Okay, so with that, if we run that, we've passed our test. So now we've got a bit of refactoring to do here. So the first one is that um, our IDE is actually helping us out here. So we see this little warning. We also see this warning sign up here. So if we look at this warning, it says our input of greater than 1 is always false. Well, that's because in our for loop, we made that our condition. So the only way that we get out of this for loop is when this is false. So this line is no longer needed. So we just delete it. Rerun that test. We're still green. Okay, so let's see. Do we have any other refactors we could do here? Well, when we come in, now that we're checking for the input to be greater than 1, we no longer need this end input is greater than 0. We know we're greater than 0 because of that other condition. So we can take that one out too. All right, so we've done that. Let's make sure we're still good there. Yep, we're passing there. So, and staying with my minimalist theme, I can do that because this is now just a one-liner in my for loop. So I kept it indented for readability so we could see that it's a nested for loop and what our action of our for loop is. And if we run that again, we're good. So now we've got, what do we got here? 1, 2, 3, 4, 5 lines of code to do that. We have a ton of tests to verify that it's good. And oh, we actually have a couple things up here that we're not using. And we can see here. So we do have some refactors here. So I can go ahead and take those out and rerun our test to make sure we didn't break anything. And we're good. So we've got our clean tests. We've got our clean code up here for prime factors. The only thing left to do now is to see if our feature passes, and this is our behavior test. So we'll take our behavior test, and what we need to do is, because this is a kata, I've already done this part, and I just had these commented out, so I'm going to uncomment out where I'm calling my method here in my import. I actually don't need, because we're in the same package now. So I can just go ahead and remove that and just go to my features file, and with the Cucumber integration that we did, I can run this just like a unit test. So I'm just going to run my full feature, and we're passing. So everything that we have is running as expected. We've satisfied the conditions of the story. So if I go back to my story and check my ACs or acceptance criteria, we were given a 0 or a 1 and we returned no factors. We tested that. We know that works. For prime numbers, only return the inputted number. We had a scenario for that. As a challenge, you could add the scenario for 0 or 1. For multiple prime factors, we listed this. We actually used this exact example from the story as a scenario and tested that, and we know we're getting this result back. So we've covered all of our ACs in our story. At this point, we're done, and we've completed our kata. So now that we've completed it, we want to reset it for tomorrow's exercise. So how do we reset this so that we can come back in and do it again? So the first thing we're going to do is we're going to go into the step definitions file that I have, and I need to re-comment out this method. And that's just because it's going to give us a compilation error once we do the rest of the reset. Because once we reset, we're not going to have our test. So the first thing we're going to do is delete our test. And I opted for a non-safe delete on these just for the sake of time. And we're going to go ahead and do a package delete on this. This will take care of our class too. So we're going to get rid of that. We got to do that twice because it wasn't an empty package. So we do that. So now we have no production code. We left with just our BDD feature file, our package with our step defs that have the commented out method, and we're ready to do this kata again. So that is our kata completed. We're ready for tomorrow's practice. And if you like the video, please give a like. If you have any comments, please leave them below. And remember that tomorrow when you come in to do this, you can jump right to that marker and start right in with the kata. Should take you about 15 minutes when you get into a routine. So hope you enjoyed this, and we will see you on the code side.